All right. Hi, everybody. Welcome to December's webinar with NA. Really appreciate everybody joining live today. We've got a really neat presentation, and I think we'll have an interesting Q&A as well today. So our speakers that are joining us are Michaela Freeman and Laura Nelson from the Pacific Northwest National Laboratory. Michaela is a research scientist with the Pacific Northwest National Lab. She focuses on environmental and socioeconomic effects of marine energy and plays a lead role in several projects aimed at identifying opportunities for co-locating offshore aquaculture with marine energy. She also conducts work related to environmental effects of marine energy, outreach and engagement, international collaboration, and marine policy. And joining Michaela as well is going to be Laura Nelson. She's a postdoc, also kind of focuses in the same kind of arena, working on interdisciplinary work with communities and climate change. So identifying solutions and opportunities with stakeholder engagement there. So really appreciate both of you all participating today and spending some time with NAA. And again, really thanks for everybody for joining live. Just a little bit of housekeeping. First off, we really appreciate this month's webinar sponsor, Jamestown Seafood. Jamestown Seafood produces both shellfish and fish. They sell it wholesale as well as shellfish seed. So be sure to check out their email, phone number, and information and reach out to them. So thanks a lot, Jim, for sponsoring this month. Everybody is on mute just for right now. So your cameras are off or on mute. Feel free to use the chat box that's open to everyone. If you want to go ahead and put questions in there as we're going through the webinar today, that's great. And once Michaela and Laura wrap up the presentation, we'll just open it up to a Q&A session as well. So feel free to raise your hand, anything like that, and we'll hopefully have a good discussion today. So with that, Michaela, I'll turn it over to you.
Thanks, Charlie, and thank you everyone for being here today. We're really excited to talk to you a little bit about marine energy. As Charlie said, maybe a new topic for a lot of you joining here today. But Charlie did a great introduction for both of us, but I'm Michaela Freeman, and I'm here today with my colleagues Laura Nelson and also Lizelle Garavelli from the Pacific Northwest National Laboratory, or PNNL. And today we'll be presenting on behalf of our larger team listed here, talking about the opportunities to use marine energy for aquaculture with a focus on research with the Jamestown S'Klallam Tribe. So for today's webinar, our goal is to really share information on research for co-locating marine energy and aquaculture. This is really a time for us to share a little bit more about marine energy and its potential application. And we also really at the end want to hear from you, your thoughts and your feedback on this. So today we'll start by sharing some background on marine energy and on co-location. We'll follow that up, mostly focusing today on details of our research with Jamestown, and then we'll give a really quick overview at the end of 3 research studies we've worked on to just highlight the various applications of marine energy for aquaculture. So this research itself stems from the U.S. Department of Energy's initiative called Powering the Blue Economy. This work, as well as everything you'll hear today, is funded by the Water Power Technologies Office within Department of Energy. And overall, the Powering the Blue Economy initiative aims to look at marine energy for non-grid or alternative markets. So one of the areas of focus within this is power at sea, such as providing energy for ocean observations or aquaculture. So, of course, our focus within that is co-locating aquaculture and marine energy. Through this, we think there's possibility to help move towards, of course, low carbon sources of power, but it also has the potential to reduce conflicts with coastal uses, minimize environmental impacts, help achieve a sustainable product potentially, and lead to opportunities for sustainable development. So when I say co-location, what I mean is marine uses developed within the same space and timescales. And then for our work specifically, it means integrating and powering aquaculture with marine energy. So this figure illustrates some of these possibilities for marine energy's uses that we see for various aquaculture operations. As I'll mention in a few slides, we've already seen some demonstration projects and research that have shown success and overall viability to deliver power to aquaculture operations. But really, aquaculture is still a new application for marine energy, and there's lots that we still want to learn and knowledge we want to gain. So through this research, we're really working to build our understanding regarding the energy needs for aquaculture operations and the ability to address those needs with marine energy. The next few slides, I really want to give a background for any who aren't familiar with marine energy. So, marine energy itself, the way that we define it, is all forms of energy that are derived directly from the seas and oceans. So, this includes wave energy, tidal energy, ocean current energy, as well as thermal and salinity gradients. This does not include offshore wind. So, I'll just note that, at least for our research. So, so far, we focus really on wave and tidal energy for our research efforts. Marine energy overall is really predictable, reliable, and a renewable source that can provide power at sea. For the next slide, I just wanted to show some examples of different marine energy devices. As you'll see here, there really hasn't been a coalescing around a particular design, and therefore we think this is a great opportunity for many different designs that range in scale and size and can fit various aquaculture operations based on their location, their scale, or their energy needs. And I should note that marine energy is still an emerging technology and it's still in development. Apologies, I'm going to try and mute myself while I cough. So we've already seen some demonstration projects and research that have shown success and overall viability to deliver power to different aquaculture operations. As you can see on this map on the right, which shows these case studies of co-location of marine-based aquaculture and various renewable energy applications. So these include marine energy, which are highlighted by the yellow and orange kind of balloons, and also green, which are hybrid marine energy and other renewable solutions. And we've seen some of these all around the world. I have pulled out one of these successes to highlight here, which is this wave energy device shown on the left, which was specifically developed for applications like aquaculture. And it was deployed within a nearshore salmon farm in Scotland. And it produced power during its 18-month installation and provided energy to the farm. So, we're excited about this opportunity and we're looking to continue to advance it. So with that background and context covered, I'll pass it over to Laura, who will share information on our current research effort. And before I do that, I'll just note that throughout our presentation today, Lizelle will be adding in links to things that we're referencing in the chat. So she just added that ocean energy systems report we did that this figure comes from. So over to you, Laura.
Great, thanks, Michaela. So yeah, like Michaela said, I'm going to give a little intro into the project that we're working here in Washington to think about co-locating community scale aquaculture and marine energy, and where we're partnering with the Jamestown S'Klallam Tribe. So we're kind of thinking about this project at two different scales. One of them is to use spatial data, which we'll talk about a little bit more in detail later, to really think at across the Salish Sea and think about areas where it might work to power, to co-locate aquaculture and marine energy. We're also working in partnership with the Jamestown S'Klallam Tribe to take a more detailed look at their existing aquaculture facilities, understand the energy needs there, and assess the resources at those locations to see what the opportunities might be like to power their existing facilities with marine energy. So just so you can get a little sense here of the region that we're talking about, PNNL has a couple of campuses around Washington State, and the Jamestown S'Klallam Tribe is located on the Olympic Peninsula with facilities sort of throughout the Salish Sea, Hood Canal, and the Straits of Juan de Fuca region. Next slide, please. So the individuals at Jamestown that we are primarily working with are people that some people on this webinar might know. Jim Parsons, who's the head of Jamestown Seafood, and Liz Tobin, who is our head shellfish biologist. Unfortunately, both of them had some travel and couldn't join us here today, but we have two slides that they developed just to give a little background about what their motivation and their interest in participating in this project was. So Jamestown S'Klallam has some aggressive carbon mitigation and like a carbon neutrality strategy for the tribal facilities, and this includes the aquaculture operations. And so they were interested in participating because some of the aspects of this work directly support some of those strategies. So as I mentioned, one of the aspects that we are completing as part of this work was to take a close look at their facilities and do an energy audit to understand sort of the energy needs and usage, which in the context of this project helps us understand sort of what specific aspects of the operations might we be able to pair or power with marine energy. It also gives the tribe a really detailed and more nuanced understanding of their energy uses and needs, which can help with energy efficiency measures in those locations. The other strategy is just that they are looking to use and promote clean energy wherever possible, and sort of taking a broad look at all of the options, and that includes ideas like marine energy. Next slide, please. So here, just wanted to share like a little bit more in some of their own words about some of the motivation, and just that the tribe is really committed in recognizing the immediate threat of climate change and wants to pursue all options to protect their culturally important resources, and this includes the aquaculture operations and looking into things like the potential usage of marine energy. So just so we can get a little bit more of a detailed understanding of what some of those aquaculture facilities look like, and think about, just understanding what we're talking about here when we're saying that we're trying to think about powering these with marine energy. The tribe has 3 current facilities. One is a Flepsy in a marina along the Straits of Juan de Fuca. They also have a shellfish hatchery at Point Whitney in Hood Canal. And then there is a research partnership with NOAA, where they are looking at the possibility of raising sablefish in net pens. So we're thinking about both finfish and shellfish aquaculture as part of this project. We have 3 main objectives, and you'll see like in the other studies that Michaela talks a little bit about later, we really have these kind of same 3 pillars going out throughout these different efforts, potentially with a little extra effort in some of the different aspects, including in this project, we are focused a lot on outreach and engagement, which is some of our motivation to be here as part of this webinar today. Both from working with Jamestown to develop some materials that kind of address some of the concerns about marine energy and what that might mean to put those kind of devices in the marine environment, but also just more broadly to sort of spread the word about the possibility of pairing marine energy and aquaculture, and sort of what the sort of like joint benefits that could come out of these co-location opportunities. We're also really interested in hearing from this crowd, and I'm going to talk in just a moment about an additional sort of like outreach effort that we're doing. But generally, we're interested in hearing from the aquaculture community regarding questions that people might have, things that they're interested in. Just what are some ways that we continue to sort of develop additional informational resources to help people feel like they understand and that their questions are answered about the idea of pairing marine energy and aquaculture. So the second, just go back. So the second objective is this energy assessment that I mentioned before, which is really to do an in-depth review of the energy systems to get a better understanding of the energy needs of the aquaculture facilities. And then the third is a spatial analysis, in which we're using spatial data and regulatory parameters to try to identify locations that might be suitable to pair for the co-location of aquaculture and marine energy. So like I mentioned, we are in the process of developing all sorts of outreach and education materials. One of the first things that we've got going is that we now have a website that is like through the Pacific Northwest National Lab that contains information. Please, I'll just put the link in the chat. Contains information about this project, as well as just some background information about marine energy in general. There are a few other parallel projects that are also happening at the lab to look at this. And so it's a good source of information about all things marine energy and aquaculture. We're hoping to also in the future have we're going to post this webinar, or we're going to have some additional fact sheets there. So kind of continue to look back, check back on this website if you're interested in more information. And then finally, from an outreach perspective, also want to make a plug for a study that we are doing. So like Michaela mentioned, the marine energy as a technology is still a little bit in its infancy. There are a lot of different designs, and also the idea of pairing it with pairing marine energy with aquaculture is like a little bit nascent and just in a pilot stage kind of around the world. And so what we're trying to understand is for people connected with the aquaculture industry, what are the sort of like valuable or beneficial characteristics of energy that you see for aquaculture operations. These could be like environmental benefits, they could be cost benefits. Some of it could be like the ability to get energy into remote locations that are otherwise hard to power or are off the grid. And all of this is going to help us understand how to best sort of like design and think about marine energy systems that could really benefit the aquaculture industry. And so we've developed an online activity called QSOR, in which we've actually come up with a list of about 20 characteristics that describe energy benefits. And we're asking for anybody who is interested in participating. What you do is you will rank those benefits in a distribution like is shown on this slide. So it's kind of like a pyramid. And what that does is it gives you an opportunity to only kind of pick a few things that you think are really important and then a few things that are the lower on the scale. And what this does is help us understand, what do people think are sort of the shared important common benefits of energy for aquaculture operations. So we're going to post the link again at the end. If you have any questions or if you're interested in participating, you can click on the link. Like I said, anybody who has a connection or expertise related to aquaculture is welcome to participate. And if you are interested in having somebody from our team actually like walk you through the effort, that is an option as well. And we will share an email address that you guys can reach out to if you have more questions or if you're kind of interested in having that opportunity to be walked through the activity yourself. And I'm going to turn it back over to Michaela.
Thanks, Laura. So the next objective within this research is a spatial analysis, which Laura already gave some insight into, but overall this aims to assess suitability for co-location by identifying potentially suitable areas for this project, specifically for wave or tidal energy and aquaculture within that Southern Salish Sea, which is our research study area. So to start, we define key parameters with ideal conditions for co-location. These were based on current research as well as discussions with our Jamestown partners. Some of them are listed on the right here. So some environmental parameters included wave height or tidal current speed, benthic habitat. Some existing uses were included like navigation routes, and then some regulatory aspects like critical habitat. And then with the guidance from our Jamestown partners, we also included culturally important and/or sensitive areas. So to find suitable areas, we defined constraints for each parameter. These were our ideal conditions based on what method needs for both marine energy and aquaculture. And so some examples of this is the wave power constraint was based on the wave resource needed to power aquaculture operations. That's one of the most important ones to find viable wave resources. However, for wave height, that constraint was really based on limits for the safety of aquaculture equipment in general operation based on conversations we've had within the aquaculture industry. In other cases, like the existing uses, these were set to exclude areas like those with established navigation routes. And then there's some other specific parameters, like for ports, we actually wanted to be within close proximity to ports for our suitable areas. And so those are set within a minimum distance to them. So there's a lot of information I'm going to present on this slide here to digest, and I'm not going to walk through all of it, but I did want to show a few maps of those parameters and data sets that we included in the spatial analysis, just to give an idea of that data input. So on the left here, we have the marine energy resource availability with wave energy on the left and tidal energy on the right. For the wave energy, the resource is really abundant off the coast of Washington, but within that Southern Salish Sea study area, it's really not showing to be a viable resource. With the scale of the tidal energy map on the right and the resolution of the model, it does make it a little challenging to see here, but there are areas where the tidal energy resource may be capable of fulfilling those power needs of aquaculture. And I've shown this zoomed in portion of the map here to kind of show you what some of those look like. So we found that areas for tidal energy that are most suitable have a minimum of 0.3 kilowatt per meter squares and a maximum of 2.8 kilowatt per meter square. So that's really what we're looking for in that tidal power range. Based on this, you can see that within the Southern Salish Sea, really tidal energy is the most suitable resource, and that's the one that we'll focus on for our rest of our presentation. On the right, there are various environmental and use considerations that we've included the data for. I won't go through all of these due to limited time, but I did just want to show them to highlight the complexity of finding suitable areas amongst an already busy sea, particularly within this Salish Sea, Strait of Juan de Fuca, Puget Sound area. So we took all these data sets and we overlaid them with those designated constraints. And the outcome is the map shown here that shows potentially suitable areas. You can see that suitability score bar at the top. And we have highlighted some of the areas. Let me click. With the highest suitability scores here. So some key findings based on this is that highest potential suitability is generally located slightly away from the shoreline. This makes a lot of sense, and it's really due to the fact that most areas close to shore have multiple environmental or what we're calling a logistical consideration, such as those limiting parameters that are noted on the slides here, as well as beaches or cultural sites. The middles of channels and canals and the Strait of Juan de Fuca also have kind of lower suitability because of navigation routes and underwater cables. So with the spatial analysis, the next steps are really to take these results and to identify tidal energy technologies that might fit the available resource. And we're looking at both what can be applicable for Jamestown's operations as well as future aquaculture operations within the study area. So the final objective we want to highlight in our study is the energy assessment that was carried out on those 3 Jamestown aquaculture operations that Laura mentioned. These are their operations in Washington State, as shown by the pictures listed here. So as Laura mentioned, the John Wayne Marina has a FLEPC for oyster grow out. Point Whitney, which is shown on the right, has algae production, geoduck farming, and oyster processing. And then in the middle, the Manchester lab has a sablefish program, which includes grow out of those as well as growing feed rotifer for the sablefish and harvesting. So for the energy assessment, actually I'm going to go back. The energy assessment itself included in-depth review of these systems, which included their seawater pumping and filtering, the heating and cooling of water, algae growing processes, and additional process plug loads. This is really the energy needs of aquaculture operations is really a knowledge gap within the literature regarding co-location. And so this was really necessary to help fill some of that knowledge gap and help us towards understanding if and how marine energy can provide energy for aquaculture, since this is really limited data available here. So the goal was really to identify energy use at these facilities, as well as also in the process to explore potential high-level opportunities for savings. So the energy assessment captured the energy use for these facilities, and I've pulled some of those summary results and figures here on the right. So some key results I wanted to pull out is, first of all, the primary energy source for Jamestown's operations is electricity, which has consistent energy use year-round. There's a very small amount of propane use as well. The graphs on the right show the total estimated energy consumption on an annual basis, shown by the top donut chart, and on the bottom in a monthly basis for all 3 locations combined. And each of these are broken down by energy and use. So the largest energy use is from pumping, followed by water cooling, which is consistent with the 24/7 use of pumps and the cooling requirements for the sablefish broodstock at that Manchester lab. Lighting and water heating are the next largest uses. Apologies. So in doing this energy assessment, the team was able to create energy baselines for Jamestown's aquaculture operations. And using this information, we've been comparing it with the marine energy resource potential and the spatial analysis results to identify opportunities for co-location. The next steps here, we're actually going to include Jamestown's Kona seed facility in this, which is really exciting because we'll have the full seed to selling and market, like expansion of all of their facilities. So that'll be really interesting to see how energy use varies in the different operations. I will quickly mention a really exciting kind of win from this energy assessment that Jim shared with us recently, is that they were able to use the outputs of this study to inform upgrades to their system, which they'll be implementing in the near future, and they're expected to lead to increased energy efficiency and cost savings. So that was a really exciting outcome of this energy assessment. So for the next few slides, I'm going to talk about different opportunities for aquaculture and co-location, just to show some of the breadth of studies that we've been engaged in, as well as to show the different opportunities within the aquaculture industry to apply marine energy. So overall, as Laura kind of mentioned, we've taken similar approaches with spatial analysis or outreach and engagement. I'm going to really highlight some of the key findings for these, and on that website that we'll link again, you can find more information for each of these. So this study explored the co-location potential, looking at offshore, or if y'all have seen the study that came out that I still need to fully read, maybe exposed aquaculture and wave energy off the coast of Hawaii and California. So we used a similar spatial analysis. We compiled information on aquaculture, offshore aquaculture energy use, and the outputs were these two maps. They're a little bit different. So the one on the left shows suitable areas. Those are outlined in black off the coast of Oahu. We started for both of these with a regional spatial analysis and then dove into some of the suitable areas to find like locally available opportunities. The map on the right is a little different. This shows our assessment where we were looking specifically at the Southern California potential aquaculture opportunity areas, which these are outlined in black in the map here, and looking at seeing if these align within our suitable areas finding. You can see around the Santa Rosa Island, Santa Cruz Island, there's some overlap with that medium suitability, but really we saw higher potential for suitability up the coast in Northern California. And Lizelle will link the paper that we published on this study. So another project we worked on assessing co-location, specifically looking at offshore aquaculture and integrated multi-trophic aquaculture with wave energy around Puerto Rico. I think I see Donna on the phone. We worked with Mana Fish Farms for this, as well as some inputs with University of New Hampshire. So we really appreciated that partnering with the aquaculture industry with Mana and being able to look at what the systems look like using this from the Aquafort from University of New Hampshire. And we got to think more about how we integrate the two systems. And I think there is a paper that Mana published on, or a report that they published on the integration potential, looking at it more from kind of an engineering perspective. So within that as well, we also did spatial analysis to find suitable areas. You can see the results on the map here. Again, that same kind of suitability score. And we found several suitable areas. So what we've been doing is taking that information and conducting community outreach around those areas, some of which are highlighted here. And then we're also assessing potential wave energy technologies that are available for co-location. I should mention all of these studies are really just exploratory to find the potential. There's no current projects that are happening at the time or any plans to go in the water, but we are trying to figure out what the current needs are and what the potential is. So the last study I want to highlight here is our colleague at PNNL has been exploring using tidal energy for shellfish and kelp aquaculture. She's looking at tidal devices, such as the one shown on the left here. So you can see this is another example from those I showed at the beginning of the presentation of those varying designs. And this one here specifically works in lower current speeds and may be well suited for these operations. So she is exploring the potential at operations specifically in Northern California and Humboldt Bay, and looking at how we can use these tidal devices for lower current speeds to apply for shellfish and kelp. And with that, that is all the material we have today. We tried to give you a really high overview of some of the research that we're doing here. So I know we went pretty quick through them. We're happy to answer questions, but before we hand it over for Q&A, I've put the link and the QR code to the Q-Sort. Again, we would really appreciate any feedback you want to give us through that activity. And then at the bottom, I've shared a QR code, and I think Lizelle will put links to both of these in the chat This QR code at the bottom for more information is to our PNNL website that Laura mentioned, where we have more information on all of these studies. So I do want to thank you very much for being here with us today. I want to thank our larger team that's worked on both this project with the Jamestown, both the PNNL and our Jamestown colleagues, as well as others involved in these last studies I highlighted. And I would like to thank support and funding from the Department of Energy Water Power Technologies Office on all of these projects. So with that, thank you so much for having us here today. And Charlie, we'll hand it over to you to run the Q&A.
All right. Thanks so much. Just super interesting. It's some of our webinars we present kind of things that have already happened or current issues. This is kind of, you guys are really pioneering something that there's no doubt that there's viable applications here between co-locating and, getting more sustainable energy into aquaculture facilities. And I just want to congratulate you all for, your work with like community engagement and what we're doing here today is, helping you through feedback and engaging with the farming community at the front of this, I think is going to be a really important part to successful outcomes in the future. So this is just really neat to see this presentation and all the work you guys are doing. So yeah, we're opening up to Q&A. If you'd like to raise your hand, there's a little feature at the bottom of the Zoom toolbar. Feel free to do that. I'll take you off mute. If you have any comments or thoughts or experience that you could share with Michaela and Laura. And as well, of course, stick things in the chat box and we'll go through some questions there. And in the meantime, I'd like to just hear a little bit more about like maybe some more of the nuts and bolts of technologies that are out there. For wave energy, farmers, whether you're shellfish or net pens, you're really trying to avoid super high energy wave sites. What kind of technologies are available right now for wave energy, like low impact wave energy? So.
Yeah, that's a great question. And I will maybe switch to the slide real quick with some of the technologies on them. So the wave energy devices, you can see three examples in the middle here. These are just some examples from the industry. There's ones that look very different. The ones on the left, you can kind of see their scale and proximity to the boats nearby. There are smaller scale versions that have been tested and then larger scale versions. So I think there's a real breadth in size that can be applicable to different operations. Of course, that's something we do have to acknowledge that there is kind of at its face potentially a mismatch between aquaculture wanting to be in calmer environments. And of course, wave energy needs a resource to be able to function. And so what we're doing in the approach we've taken with a spatial analysis is to find through the data if it's a feasible at first. So that study I mentioned in Hawaii and California was kind of our first effort to probe into this and be like, these kind of might be mismatched, but where is it possible? Is it viable? What does that look like? So that's really why we've led with the spatial analysis. As far as the different technologies that are available, particularly wave energy devices, through that project that we did in Puerto Rico as part of it, I briefly mentioned we looked at wave energy technologies. So we sent out a request for information to wave energy developers for aquaculture to try and learn a little bit more about how do we actually integrate them? What do these devices look like? What kind of wave climates do they need? And we were really pleasantly surprised. We received 16 responses to that request for information. So obviously that's a breadth of different devices. Some said they could be ready in 6 months, which, maybe is a little bit more of an ideal situation, but or maybe optimistic situation, but there are potentially 16 various devices and developers that are interested in working with aquaculture for the marine energy devices. So that really showed us that there's this interest from the marine energy community to continue to explore this, to apply their devices. They were all different scales and sizes. And so it really just kind of reaffirmed that potential to use these. I am not an engineer, so I won't go too much in the specifics of the technologies, but we do have engineers on our team. So if you have questions about that, we can, of course, link you up with someone, or, we'd love to hear what information might be useful in the future. So if that's something people want to know more about, we'd be happy to do another webinar, whether through NAA or a different source, to kind of provide some of those details.
Okay. All right. Well, don't be shy, everyone. You feel free to drop any other questions in there, and I'll keep firing away. I still had a few other ones. I guess similar to the wave energy. Can you talk a little bit more about offshore wind and how it may be viable for power and aquaculture?
Yeah, definitely. So, what we've seen so far, at least, is not necessarily offshore wind powering aquaculture, but more so it co-located in the same space, sharing space within potentially those areas between like offshore wind turbines that are limited or maybe excluded to other uses, and that might be viable. So, it is definitely a very different application of that. The offshore wind turbines are much larger in scale and size. And so I think that's what we're seeing. I know there's been some studies that have looked at co-located actually offshore wind and wave farms. Could you put wave devices within those offshore air areas, offshore wind areas? Um, and so maybe there's a potential to have, multiple uses coexisting in the same space. It's offshore wind, it's wave energy, it's aquaculture. I think that's what we're really excited to look towards is how do we use the marine space in a way that's environmentally responsible, it's sustainable development, and it's kind of bringing uses that can be compatible with each other together.
Awesome. So real quick, there was a question from the audience. Well, yes, we are recording the webinar and we'll share that out through our membership email news as well as it'll go on our webpage and our YouTube channel. So look for that announcement soon. You can go to nationalaquaculture.org, find our news feed, and we do have a public subscription available there. And of course, everyone should join the National Aquaculture Association, then you can get all that great news directly. So Rebecca's got her hand up. I'll go ahead and if you should be able to unmute yourself now, Rebecca.
Hi, can you hear me?
Yep.
Yep.
Hi, I'm with Taylor Shellfish. I have a couple questions. One is what are the challenges, the foreseeable challenges with permitting with these devices that are in the water? I know that most in aquaculture know that permitting, there's a lot of hurdles to jump over whenever you're trying to install or place anything in the marine environment and depending on location. And then my other question is, what kind of maintenance plan comes along with this equipment as far as just, how frequently, who is responsible for maintaining these and monitoring these, especially after storm events, and then just your regular, what is the frequency of kind of that regular monitoring and maintenance?
Yeah, those are all really great questions. I'll maybe start with the second one first and then come back to the permitting. As far as maintenance, it definitely depends on the device type. There may be yearly maintenance or 5-year or 10-year maintenance, and those look a little bit different for some devices that we've seen. I'm mostly talking about wave energy here. Sometimes they have to be brought into shore, sometimes they can be serviced at the location. It really depends on how the device is built. There's some tidal energy devices that we're seeing where you can access them and maintenance them at the location. So again, another kind of example of each device is really different. Um, these are the sorts of things that obviously are going to be really important to figure out and consider. And I think as Charlie mentioned, like this is something we're really exploring and at kind of the forefront of does it work? And those sorts of questions are really useful to get us thinking about, okay, once we've integrated the two and maybe they're deployed together, what does that look like for the long term? And so those are things we're kind of trying to explore as we can. We're doing a little bit less of that, obviously, because we're in more of the initial stages of the feasibility and how they work together. But certainly, like um, insurance is going to be an issue, and yeah, who's responsible for certain things and making sure they don't interact in the marine environment, and maybe net pen and wave device are all things we're kind of trying to consider. With the permitting, yes, that is absolutely a challenge and something we're trying to explore. Within the US, we have had some marine energy devices that have been deployed and permitted. We're seeing more of them. But it's certainly still a challenge. Lizelle and I work on a project that's looking at environmental effects of marine energy, and that is all to help understand what those potential environmental effects might be to help permitting and try and advance marine energy in a responsible manner. So that's some work that we're doing as well to help move that forward. But I think, for both aquaculture and marine energy, it certainly is a challenge to get them in the marine environment. So something we're looking at is when you consider permitting, does bringing these two uses together, does it make it more challenging? Or are there actually synergies where there might be opportunities there? So maybe it's things such as you're going to monitor for maybe entanglement for one of the systems, the aquaculture system. Well, you'd also want to do the same for a wave energy device. So can you bring those needs together so that there's cost sharing or other things like that? And I think for both of your questions, one of the answers I have is we're working on a guide for co-location, and that's hopefully going to address some of those things. Of course, we don't have all the answers. We won't have all the answers until someone starts to go through a permitting process for a co-located deployment. But we hope that the guide's kind of a living document that can get updated over time. We have a draft we're working on right now. We hope by the fall that we'll have something that's publicly available and can get to answering those questions. Something in the document I mentioned that Monofish Farms worked on was trying to get at some of those questions. Is it better to permit an aquaculture facility first and then add in a wave device, or is there a certain method that you might want to take? So right now, unfortunately, a bit more questions and answers, but hopefully I kind of got at some of what you were asking.
Yes, thank you. It's just good to know that those are some of the questions that are being asked as these projects move along. So because I can see that they would definitely be one of those kind of make or break
Yeah.
points where it could either be a successful venture or you would hit a wall and it would not be successful for a farm. So
Absolutely. And we're interested to hear from all of you about like what are the permitting things are opportunities to align together or things that are challenging that maybe there's an opportunity there to help out with, or, areas you're running into barriers that we really, need to consider a lot if co-location is going to be a reality. So yeah, those are the sorts of things that we really want to hear from the aquaculture community.
thank you.
Okay. See, Maria, go ahead and unmute you.
Oh, aloha. So my name's Maria Haas. I work at the University of Hawaii Hilo. And so you guys probably know that the traditional Hawaiian fish ponds are really important in our aquaculture landscape out here. But there's a lot of interest among the aquaculture community, I think, in alternative energy use. So I was really interested to see that you're working with some of the First Nations, and I'm curious if there's been any kind of cultural dimension that you needed to consider in this, and how it works with sort of these, I guess, arrangements for co-management in the coastal areas. Just any guidance or advice on what your experiences have been in that sense?
Yeah, that's a great question. Laura, do you want to start first, or do you want me to?
Sure. Yeah, I mean, I think, well, there's a couple of aspects to kind of like working with Jamestown and the cultural aspects. And one of those is I think we on those two slides that we mentioned, like this effort is really in alignment with some of the independent work that Jamestown has been doing to think about their own kind of carbon footprint and their climate strategy and their just a lot of the work that they're doing. And so we are, from an outreach standpoint, also, I think continuing, I think we've got these two parallel efforts. One of them is sort of outreach with the greater aquaculture community, efforts like we're doing here today. And then something we're still kind of like working on with our partners at Jamestown is more targeted outreach for that community to think about like what's the information, be it about marine energy, about climate change, about aquaculture, about all of these things together. Like what's the kind of information that our partners there think needs to be shared with the greater community so they can understand how an effort like this might be in support of preserving important cultural resources. I think within the community too, there's been a greater effort to on the part of some of the team that works on aquaculture to really communicate about how aquaculture itself um, is, while it might not sort of like be the traditional like harvesting of, or more like naturally occurring shellfish harvesting that they still continue to do there, but how aquaculture also fits into this just like process of stewarding cultural resources. And so I think, yeah, we're just kind of working with them to try to figure out what's the communication on that front. Um, and then I think from a little bit more of just a practical perspective, when it comes, or like logistical perspective, when it comes to some of the spatial analysis that Michaela was talking about, we have worked with them to ensure that when we're looking at some of the more like some of like detailed aspects from a spatial perspective, that has been some cultural information included in part of our assessment there. And then just, making sure that we do what we need to there to kind of run some of these like layers of what is being shared as part of the project, kind of like what is being sort of shared from a spatial analysis on a broader perspective to make sure that we both like include and respect those cultural aspects of shellfish harvesting, but also that we are sort of respectful of the information that should be public versus like kept within the tribe.
Yeah, and I'll maybe also just add that we have been really purposeful in this partnership with Jamestown. We've subcontracted with them because we want them to be partners and integrated into the research that we're doing, and a part of kind of, as Laura said, like making sure that the efforts through this research study achieve some of their goals as well. So um, yeah, hopefully we answered your question, or at least got at most of it. I think some of the code management that you're talking about, I think we're still in like too early stages. Again, just kind of probing it, like, what is this potential? I think that's maybe one of the challenges with a lot of this research is there's so many questions to answer, and we're really trying to focus on what does the feasibility look like and how do we make that a possibility, and kind of take one step at a time. But those sorts of questions are absolutely really important to consider as we go, and hopefully we'll dive into more as this research progresses.
All right, folks, we still have time for a few more questions. Really great ones so far. So, um, thinking a little bit more about the permitting question, Rebecca, that was a great question. I had the same thing in the back of my head. I don't like to talk marine permitting on Friday afternoon. So, but when it comes down to an Army Corps permit, it's really going to be very specific, to the you. I see. I appreciate the challenge y'all have of like this is a big picture type thinking, but when it comes to, especially on the permitting side, it's going to be you really have to have the exact device that you're going to use, exactly where it's at. It's just the way the Army Corps permitting process just kind of works. But I think it's good to hear that some of these wave devices or energy devices have been deployed and permitted already. That could certainly help facilitate that. But I imagine there's a lot of synergies, whether it's permitting or use between marine energy and offshore farms, especially kind of in the spatial analysis arena.
Mhm.
And yeah, can you talk a little bit more about like what are some of the bigger, more important spatial analysis, variables that you look at when you're trying to identify those sites?
Yeah, absolutely. And maybe I'll just come back to your permitting question first. I appreciate the rule, no permitting on a Friday, but we do, that is something we're kind of considering a lot, and something that we had a lot of discussions with Mana about as they developed their report and as we're developing our guide for co-location, which I'm like quickly trying to pull up as we talk. But we did look through a little bit of what permits would aquaculture need, what permits would marine energy need, and where do those line up? And who are the lead agencies and how do those differ in some of those requirements? So the Federal Energy Regulatory Commission is generally one of the leads. If you're grid connected, and we're kind of, does that also is that also the case if it's connected to an aquaculture system and supplying power there? we need a BOEM seafloor lease or research lease for those, which I think is a little bit different. And so where do those align and where don't they, and what does that look like? And the marine energy industry has used kind of more permitting envelope approaches to designate things that may have some flexibility. One example is off the coast of Newport, Oregon, the PacWave South Wave Energy Test Site. They've been able to permit. It did take a very long time, so I'll put an asterisk there, but they permitted a test site that can have various devices come in and test there without knowing the exact device type. That may be different for a very specific co-located deployment that already has its own challenges and its own new things it's trying to deal with. But we do have an example there for something that may need to be a little bit more flexible and how that might work. It was a very long process to get through that permitting, so I don't want to have any disillusionments about that, but we do have some examples. And we're hoping to, address a lot of these things in that guide for co-location. Back to your question about the parameters that we used, and Lizelle is here, who leads a lot of our spatial analysis stuff. So Lizelle, you are welcome to pop in and talk about this. Charlie, would you just remind me, your question was just to talk a little bit more about the parameters that we used?
Yeah, just some of the more key spatial analysis parameters.
Yeah, definitely. So obviously, there's ones that are very key for marine energy and very key for aquaculture, and then there are some that overlap. So for marine energy, I think our studies always start with, is the marine energy resource viable? Because at least, that's the perspective we're coming from. And if it's not viable, then it's kind of a moot point from the start. So wave power density is the key parameter that we're looking at for wave power. Tidal power density is the key one for tidal energy. Some other ones that are linked but not maybe are more for aquaculture is wave height and tidal current speed. From talking with the aquaculture industry, we understand that both of those are limitations for equipment like net pens and general operational safety, or just how operations are carried out. So we've included some of those. The bathymetry, benthic habitat, those sorts of things are where both really align. Both are looking for kind of that soft habitat for the most part. You can be in like rocky areas as well, but really sited away from, important, unique, critical habitats. I think the other things where they align too is navigation routes and submarine cables and some of those existing uses that you either want to or are required to steer clear of. So obviously all those existing uses in the marine environment. We've tried to include like commercial fishing as well, though many people might know that that is a hard one to fully capture. Like in Puerto Rico, we know there's a lot of fishing that goes on at the local scale, but there is no one data set. So some things like that, we have to conduct our spatial analysis. And then in that case, we're talking to communities and trying to understand, where do you fish, so that we're not including those important areas within our kind of suitability analysis. So some of them are available data sets. Some we learn more about when we kind of go into that outreach portion of the work. And then our regulatory aspects, we have endangered species habitat, critical habitat, marine protected areas, some other ones. Some of these are more acknowledgements that permitting may be more challenging within these areas rather than like a full out restriction, but are good to know. And that's why we have suitability on kind of a sliding scale rather than just a yes or no. Of course, there's some that like, if it exists there, it's going to be a pretty hard no. But a lot of them, we have this kind of potential to kind of figure out what works in those areas. And one thing that we've been doing for the Jamestown study in particular with the spatial analysis is looking at what are the limiting parameters. We presented a little bit on that today. What are those that specifically limit an area, and as their potential to kind of move around what we're finding as suitable areas based on which parameters are or aren't limiting. Lizelle, is there anything else you want to add there?
Just a quick thing on all the parameters Michaela mentioned. For example, when we started this a few years ago, we did some interview with several aquaculture developers. And for example, for current velocities, we wanted to understand what was the constraint for them. So it was for offshore aquaculture at this point, but For example, they were saying, you know, we are going to send divers to check on the net pens. We don't want the current velocities to be more than 1 meter per second. So we have constraint in the spatial analysis also for all of these parameters, some more for aquaculture, some more for marine energy, and some that are kind of similar for both. But just wanted to note that.
Yeah, good point. And then I'll mention for like each of the different projects we do, whoever we're working with, whether it's Jamestown or with Mana, we kind of fix those constraints or ideal conditions based on that particular research study or application.
Well, yeah, it's great information. You've got really a challenge on your hands to find that perfect spot. We appreciate how difficult it is just from the aquaculture side of permitting, and of course the leasing, you know, through state laws and regulations as well is going to be kind of an interesting challenge. And that's where commercial fishing, you know, a lot of state lease processes kind of, like you said, that data is not really available, and it does take that kind of boots on the ground public engagement as well to really get that information at a granular level that you need to be successful in actually deploying a project. So, yeah, I could certainly just kind of offer NAA as a resource to you all, you know, as kind of aquaculture permitting experts as you develop your co-location guide. So you reach out to us anytime. We can help you with the aquaculture side of it. So and it is a little bit different, it sounds like already. Again, it hurts my head to think about another federal marine permitting system out there. But yeah, consider us a resource for sure. I think we have time for maybe one more question, and then we'll wrap it up for today. Anyone have any other lingering thoughts or anything we'd like to have?
I'll maybe add just a small plug that at least myself, possibly Lizelle as well, will be at the World Aquaculture Conference in New Orleans. We'll be presenting on, I think you may see something similar, but we'll be there. So we're happy to field more questions, have discussions, talk to you. We may have the Q-sort available at that point as well, but we're really focused on trying to get that completed now and have some results to build on for the research, but happy to talk more for those of you who will be attending that event.
Awesome.
Come find us, please.
Well, I hope everybody does attend Aquaculture 2025, and we'll certainly be there too. So, and happy to help just distribute the word about your survey. So, well, that's great. Well, again, I really applaud you for the stakeholder engagement and working with industry closely at the front of this project. So, with that, let's wrap it up. I'll just want to note our January 31st is our next NA webinar. Be sure to tune in. We've got a pollution car. Amanda Carr with that legal office going to talk about the Endangered Species Act Section 7 consultation process. Excuse me, I should have muted when I coughed too, but she'll be giving us some updates on the consultation process. So be sure to tune into that one, and I hope everyone has a great and happy holiday season. So thanks so much for coming in to the webinar today.
Thank you. Thank you, Charlie, and thank you everyone for joining. All right.